Okay, we're going to continue with our exponent rules and just get a little harder examples. So I put a refresher of the rules at the top, and we are still going to simplify expressions involving radicals and rational exponents using the properties. So on example 1, we have c to the -9, d to the 12, -5, 6. Now, for a lot of these problems, you can do a couple of different strategies first. So I just pick one and then I go with it. So we're going to apply the power on the outside to both terms on the inside. So since that's a power to a power, that is our exponent rule, which means to multiply them. So I've got c to the -9 times -5/6, and then d to the 12 times -5/6. And you're welcome to use a calculator to multiply these fractions. It's whatever you feel more comfortable with. So let's see, if I don't have a calculator, then you would just reduce them first. These divide by 3, and then you can multiply tops, and then you multiply the bottoms. So -3 times -5 is 15/2. And you just want to leave that. You don't want to write it as a decimal. Same thing with d. 6 goes into 12 2 times, so 2 times -5 is -10. Now, the rule is always going to be that you can only have positive exponents, and I don't worry about that until the very end. So because of this negative, that means that this d term is going to go in a denominator. The c term is a positive exponent, so that stays. So our final answer, and I'm going to squeeze it in over here, is going to be c to the 15/2. And then the d term, when you move it, it becomes a positive exponent. So d to the 10th. And that's what we're looking for. But that's always going to be the default. Example 2, write the 4 expressions in descending order. So we want the biggest exponent to the smallest. So first I need to figure out what they really are. So we're going to squeeze this work in. Remember, this is to the first power, and it's power over root. Okay? So I've got x to the 1/6 times x to the 1/8. And so you have to remember that when the bases are the same, you're going to add exponents. And you can also, again, use your calculator to add your fractions. If you don't have a calculator, you'll have to get a common denominator, which this would be 24. So I'm going to write it up here. So if I make that 24, I'm going to have to multiply the bottom by 4 and the top by 4. And then 8, to get that to be 24, we'll multiply by 3. So then you add those together, and we'll get x to the 7/24. Okay? And we'll have to compare. The second one, since these are being divided, you subtract. So 1 minus 5/7. If you don't have a calculator, 1 is the same as 7/7, so this would be x to the 2/7. This one would be x to the 2/3, and then that's to the power of 4/7, so we're going to multiply. So same thing, you multiply tops and you multiply bottoms, so that's going to be x to the 8/21. And then this does not have a power of x on the top, so this exponent, since it's negative, is going to move to the top, so that's just going to be x to the 2/5. So these are our 4 expressions, and then they just want to put those in order. So you have a couple of choices. If you aren't familiar with fractions, you can use your calculator. So 7 divided by 24 is 0.29, and I'm just going to write this here. So that's about 0.29. 2 divided by 7 is 0.285. 8 divided by 21 is 0.38. And 2 divided by 5 is 0.4. So the largest one is going to be this. So this would be first. I'll put a number 1 by it. Our next largest, number 2. This is actually bigger, so number 3. And then number 4. All right. Let's look at example 3. So if we're given a function x to the -3/2, find f to the 1/4. Remember, this is our value for x. So we want to take that and plug it in. So I really have 1/4 to the -3/2. And I know your calculator will just do this, but once again, we want to practice breaking it down. So this is really 3 parts. We've got this root, which is the square root, since it's a 2, the third power, and then the negative is a reciprocal. So I call a reciprocal flip. So you can do these in any order. I like to actually do my flipping first if we have a fraction. So if I do this negative, that means I flip this to just be 4. So we really have 4 to the 3/2. And then I do the square root. So the square root of 4 is 2. So then we're left with 2 cubed. So 2 times 2 times 2 is 8. All right. Let's move on to example 4. This just means that n has to be positive, and n is in the fraction. So we want to rewrite this. So if I think of this, these are all exponents. Some have radicals, some don't. So we're going to kind of be flexible. So I can think of this as n to the -1 on the inside, since that's like the first power. And if you want to bring it up, you would make it a negative exponent. It doesn't look like that's any of our choices yet. So we have a power to a power, so we're going to multiply. So -1 times -2/3 is positive 2/3. And I see this negative in front, and there's literally no way we can get a negative. So I know that's not going to be possible, and I know that one's not possible. So then we need to rewrite this in radical form. So remember, it's power over root. So we have the cubed root of n to the second power, which looks like the third one. All right, so you just have to be flexible when it's multiple choice. All right, example 5, a lot to simplify. It looks like they just want one single power of w. So you have a couple of options. If you want, since that's a negative, it's going to move up, and since that's a negative exponent, it's going to move down. You can just rewrite this. You don't have to worry about subtracting or doing anything else if that confuses you. So I'm just going to rewrite that. And then I don't even think about subtracting. I just call it reducing. So I take 5 of those w's out, take 5 of those. So we're left with w to the 4th to the 1/2. And then a power to a power, we multiply. So 4 times 1/2 is 2. And so that matches up. All right, so now we're going to work on refreshing your memory on how to simplify radicals. So some will want you to change the radical to an exponent. Some will need you to simplify it first. So if you have a square root, you look for doubles. They come out once. If you have cubed roots, you look for triples. They come out once. So on this problem, it looks like they took the exponents and they want to write it without the radical. So we're going to rewrite this. So z to the third power over the 7th root, and that's still to the 8th on the outside. So then we multiply. You can think of that over 1, and so we multiply straight across. So z to the 24, 7 times 1. So 24 over 7, which is b. On here it looks like nothing has negatives, and it looks like they simplified the radical. So because this is a 3, we're going to look for triples. I do like to rewrite the negatives, so I'm going to think of this as the cubed root of the 27. Since the a has a negative exponent, that goes in the denominator, the b3 and the c2. So we're going to break this down, and we're going to look for triples. So 27 is 9 times 3, which is 3 times 3 times 3. B3, I'm going to write out 3 of them, C2, and then on bottom we've got 6 A's. So you look for 3's, and then they only come out of the radical once. So we're going to write a 3 on the outside. We've got 3 b's. I don't have enough, so those are going to go back together, and they're going to be inside the radical. Here's 1a, and here's 2 triple a's. So we're going to have 2 a's on the outside. So that one is so close, but they don't have the a on top. Oops, they're right, that a goes on bottom. Since it was on bottom, good catch. But they have a 3 on the inside, and we don't have any 3's left because we had them. So I know it's not this one. And then it looks like they didn't use the radicals, so we're going to change this into the power. So we've got 3b to the c 2/3 power all over a squared. And then we just have to match it. So no, no, yes. Okay, so just be very flexible. I'm going to rewrite this since it looks like none of these have the radicals. So we've got a squared b to the 1/2, and then that is also written to the 1/2 power. And then this still goes on the outside, so it can look pretty complicated. But we're going to apply the 1/2 to both of those. So remember, you multiply. So 2 times 1/2 is 1. 1/2 times 1/2, you multiply, we get 1/4. And it's still to the negative first power overall, which basically just says flip everything. So it's like all of these are over 1, and so we're just going to move both terms to the denominator. So a b to the 1/4. And notice I left my 1 off the a because that's typical. And that matches. All right. Our last 2 examples. It looks like they're going to write them with radicals, but I'm going to wait to do that. So I'm going to simplify. We can subtract. So 2 minus 1/3. You can use a calculator. That's 6/3, so that would be 5/3. So we get m to the 5/3 on the inside. That's still to the negative 1/2. So now we multiply a power to a power. You multiply the top and the bottoms. So we get m to the negative 5/6. And the negative is going to flip this down. So 1 over m to the 5/6. And they changed everything to a radical. So I've got 1 over m to the 5th power and then the 6th root. I would try to write them out before you go to match them up. Now, I see it. Okay. X divided is not equal to 0. That's because we have fractions here, so they're always going to use that. You can kind of ignore it if it troubles you. Which expressions are equivalent to 1 divided by the 6th root of x? So this is basically, if we can read it in words, how do we translate this? So equivalent to 1 divided by the 6th root of x. So this is what I want these to simplify to. So we're going to have to do all 3 of them separately. So I'm going to rewrite this as x to the 1 over 6 divided by x to the 1 over 3, and we'll see what that is. So we subtract. So if I change this, we can multiply by 2. So this is x to the 2/6. So x 1/6 minus 2/6 is negative 1/6, and that negative flips it. So remember, that's the 6th root and the 1st power, so that is the same. Well, if we look at number 2, that actually starts out as our first step for Roman numeral 1. So then that's going to all be the same. The bottom, this negative exponent, that starts out as that step. So I know that's going to be. So it's actually all of them. All right, so now I'm going to let you practice the ones that you pick.